I haven't actually seen it before, so it was a first for me. It was actually quite good, actually. Really found it interesting.
It caught the department's imagination because they could see that they could do new things, new experiments. We could have kids working on their own.
It's so small and so compact and easy to use, and it's designed for children, which makes it easy, I suppose.
It's much speedier in a lesson. We can get through a whole practical because we're using such small quantities.
So what's been happening in school laboratories to cause this reaction? Since its introduction 10 years ago, microscale equipment has been changing the way we look at practical science. These unique kits, whose origins lie in medical and industrial labs, are making experiments click for students across the world and across the whole spectrum of chemistry, biology and physics. Microscale puts practical science within the grasp of children of all ages, and because it's so compact, if you have a sink, you have a laboratory. Practical kits, detailed and exciting worksheets, and easy-to-follow teacher's guides are available for all key stages and across the whole science curriculum. The high-quality professional development we provide helps teachers get the most from microscience. But the range of benefits doesn't stop there.
Well, I think it's going to be a lot safer than when we use like half beakers full in class, because if you spill it, you're going to like ruin the whole clothes instead of just getting one patch out or something.
If we use toxic materials, we only use small quantities of them. We don't get lots of nasty smells, so it's much safer.
I feel a lot safer because there isn't as much glass in the equipment as there would be with normal equipment, and you're a lot less likely to break anything.
Choosing microscale reduces costs, both to the school and to the environment.
It's very economical. We only use small quantities of chemicals, and if there's a breakage, it's only a small breakage and we don't have to spend so much money to replace it.
Since we've started microscience, we used to do it on a large scale. We used to chuck litres of acid down the sink, and now we have a small bottle on each bench. And so what would take about 25 centimetre cubed of acid now takes 2. So you can see the saving on acid, marble chips, things like that. So at year 10, their investigations that they do for GCSE is all on microscience. We've adapted the apparatus. AS level also.
Today, children are using microscale equipment in over 65 countries, including many in the developing world. We are proud to be a partner with UNESCO, enabling children everywhere to experience practical science for themselves. At the heart of the microscale system is the combo plate. With more than 2 million in existence, its simple yet versatile design makes it invaluable across the curriculum. Microscale is ideal in biology for systematic analysis, such as food testing. In physics, electrical circuits can be built on the combo plate instead of using larger circuit boards. Worksheets are also available on many other aspects of physics. Most important of all, microscale equipment is a proven catalyst for better quality practical science wherever it is used.
My experiment, obviously, I was distilling methylated spirits. It requires 2 kind of micro retort stands, and the way it's put up is so easy. You just literally put the retort stands in, put it on, light the Bunsen, and you're going. The larger scale distillation is much, much bigger than this one, and it takes a good 10 minutes to set up.
Yes, I like it because it's small and It's easy to store, and each student can have their own set of apparatus, and they can work then at their own pace and their own place.
The coursework now, each kid does his own piece of work, so that he doesn't have to share with anybody, so we know who's done the work, who's, you know, if we give him marks, we know it's being given to the right person. You know, people like to use it because the kids like it, they enjoy using it, and they like the noise level drops because they've all got to concentrate on their own experiment rather than anybody else's. And so, you know, these are sort of all pluses as far as we're concerned. Also, you know, it is their work and they've got ownership of it.
Yeah, well, you just move the sauce and then let it cool down a bit. Then you just change the refluxing column. Do you got the distillation? This one? Yeah, that's it. Just switch over and put it here. You're trying to collect it, put it here, and put it there. And when you're trying to reflux it again, collect it. And then, have you got the column things? Yeah, one is here.
Well, the lesson was really great. It was different because the equipment is a lot smaller than the other equipment, so we used a lot less space. And I reckon that instead of working in larger groups in smaller areas, we could do it individually, because if you work in large groups, people tend to get put out more.
Well, this is a combo plate, and it's basically used instead of like beakers, and you can put your test tubes in here, and so you can do everything on a smaller scale, which is obviously more economical. But it can also double up as one of these, which is I'm setting up to prepare to distill this product in here. Basically, we've got some oil here which is going to indirectly heat the compound I've got in here. It's going to come across, and as it goes through here, it's going to condense again, and then I'm going to collect it in this test tube here. And obviously the benefits of using something like this is you can do everything on such a smaller scale. It's just safer and more economical.
I like the microscale science because it's on a micro scale, and so it's so easy for children to use, and since I like science, it's just good. It's science is heaven.